Welcome to Lesson 2. In the previous lesson, you installed the JMeter. You learned about its folder structure and how it's built. Let's see what we'll cover today in Lesson 2, building your first script. We'll talk about thread groups, and thread groups are really the fundamental thing that delivers load or demand with JMeter. It's the virtual users that perform the actions, right? We'll talk about samplers, which is an example of how load is delivered to a target, how the requests are made, and then we'll talk about the HTTP request sampler in particular. We'll talk about timers. Timers are actually how you add delays to your test to make them more realistic. Then we'll look at assertions, which help us make sure that the right things are happening in your test, let you validate that the test is doing what you want it to do. And then finally, and really importantly, we'll look at listeners, which let you observe all of this, to actually listen to what's happening, watch what's happening during the test, and we'll use the view results tree for that. So let's start by understanding thread groups. For that, we'll want to go into the JMeter interface. Okay, so this is what JMeter looks like when it's launched. Just a test plan element and a workbench element. Using the workbench is optional, and so we won't cover it here right now. The test plan is the root of your entire script. Everything you do will live under that test plan, right? And we're first going to add a thread group. That's what we're doing in this step, right? So we'll right-click and add a thread group. So let's first step back and ask, well, what is a thread group for? And the simple answer is that its job is creating threads, but it's important to know that those threads are users, right? So here, down here where it says number of threads users. So virtual users is a term you may know, which is the number of virtual visitors to a site or to an application. So the thread group's job is to create users to execute your scenario. And the scenario will play out as we understand the samplers and all the rest of the things we're going to talk about today. So just for starters, remember that the thread group is the thing that deploys virtual users. And we call them threads here, but you could also think of them as users or virtual users. So it's the thing that adds users to your test so they can perform actions, right? Okay, so let's look at how you configure it. The most important properties are all right here where it says thread properties. The number of threads is the number of users we want to deploy. And if we were going to, launch 100 users, we would do that. And then the ramp-up period is how long we want to take to actually let those users come up to full speed. So full strength of 100, right? So if a ramp-up period is 60 seconds, that means that over the course of 60 seconds, we'll go from 0 to 100 threads. So at the end of 60 seconds, we'll have 100 threads in flight. Right? Now, the third parameter here is loop count. And you notice that for now it says the default was 1. And that's because when you're building a test plan, it's quite common that you actually would use just one thread and 1 second here and one loop count. And it's because you're just testing the logic. So when you're first building a test and troubleshooting it, you don't need to run something 100 times just to see if the logic works the way you want and if you're getting the results you need, right? When you field a test out, when you're going to ramp up to a larger amount of load, you're more likely to check this box and have it be forever, which is that the loop is going to just repeat and repeat and repeat, and you'll control how many times it iterates by the duration of your test, right? So you're going to run it for 10 minutes or 15 minutes or half an hour or 5 hours, whatever, right? And the debugging, though, we want to be like this, right? We'll come back here and we'll play with this a little bit down the road a bit. These are the main options we need to focus ourselves with. Let's move on to the next topic. So we've got our thread group. We're deploying, for now, one thread and ramping over 1 second and ramping, looping through their tasks just once. Before we move on, actually, I should mention what's going on up here where it says action to be taken after a sampler error. We're going to cover samplers in just a second, but before we do, just imagine a sampler is the thing that's actually going to take action. It's going to send a request, perform some logic, whatever. If there's an error, we have to decide what to do. Now continue just trudges on. It says, hey, we got an error, but we don't care. We're just going to keep going. Start the next thread loop would say, I'm going to stop on the error, this particular iteration of this loop, and I'm going to go to the next loop. So if we had a loop that had 5 steps in it and we got an error in the first of the 5 steps, we would exit that loop and start the first one, the next one at the top, right? Stop thread literally kills off this thread group so that this thread no longer would execute during the test. Stop test stops the entire test. but it does that gracefully. So what stop test does is says, I'm going to let any threads that are already in flight, that are already out there running, to complete before I shut it down. Stop test now, however, says, I don't care what's happening and how many are in flight, I'm going to stop it right now. It's sort of an abrupt stop, right? Okay, so that is thread group. Let's move on to samplers. So, and we're going to look at the HTTP request sampler, but let's talk about what samplers are in general first. So if I go over here and I right-click on thread group and go to samplers, we can see there's quite a list of samplers here. And the one we're going to use first, is HTTP request, right? But you can see there's others in here. There's FTP request, another network request like HTTP. There's Java request, which executes some Java. There's JDBC, which would execute a JDBC database call. There's all these other different types of samplers. And what you think about with a sampler is it's the thing that executes. It's the thing that actually is going to send traffic or going to do the work. You'll notice there's several here that are sort of programming language based. Java request, for instance. Another one you'll see here is Bean Shell. That's historically been a way to do scripting, where you're writing a scripting language. Although JSR 223 is really taking over as the main way to use scripting. So JSR 223 is a standard for embedding scripting languages within a Java program. And the most powerful language at the moment is really Groovy. And so if you're curious about that, I know we're kind of getting ahead, but if you're curious, you can just Google Groovy is the new black, and you'll see a blog post that's pretty cool about the power and speed of using Groovy with a JSR 223. But today, we're just going to focus for now. We're building up fundamentals, right? So let's go back to this HTTP request, and that's what we're going to add. Now, like anything in JMeter, we can give it a name. This is the element name, and if I were to change this to my name, and we were to leave this and come back, we'll see that it shows up there. I'm going to leave it HTTP request for now so you can glance at the tree and know what's happening, right? Let's talk about what we can set in here, right? So the first thing is, what web server are we going to hit with this request? And in this case, we're going to hit a demo server called blazdemo.com. Now, you could put an IP address in here instead if you had it, or you could put a port number if it's something other than port 80, which is the default, right? But all we need is to put that in there. And then the path. This would be the path of the asset on the server. If we want to just hit the home page, which we do for now, we're just going to put / there, right? Now, protocol, this lets us say either HTTPS or HTTP. Since HTTP is all we need here and it's the default, we don't have to put anything in this field, right? Under the method, GET is a simple page request, right? If you're familiar with HTTP protocol, POST is what you would use to actually do a login, perhaps, or submit a form. All these verbs are available, and if, for instance, you were doing a POST, you would need to either have a POST body, which is sort of a typically JSON POST body here, or you could have parameters, and those are often known as query parameters. So if I put here name of this field is username, and the value is Dave, we can see that would be sent as part of the POST request. But we want to keep it simple and just do a GET. So we'll switch this back to GET, right? So real simple, this is just going to create an HTTP request to fetch a page from this server on this path, so the base, the root path of that server, the home page, and that's all we need to know for now from the HTTP request. Let's move on to the next thing in today's agenda, though, right? Which is timers. So let's make sure that when we think about timers, we think about them right. A timer is actually not something that calculates time to figure out elapsed time in terms of how long did something take. Actually, the way we use timers is to introduce an intentional delay or a wait before an execution takes place, right? And the reason we do that is we want to have realism in our testing. We want to, a real user goes to a web page and they don't go click, 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 click. They click and then they read. And if they get to a form and they have 8 fields to fill out, they've got to fill in the 8 fields and then they hit submit. And so timers let us introduce some realism to the demand we place on the back end by adding time. And we could add a fixed amount of time, which is the constant timer we're going to talk about in a minute, or we could add random time within a range. And one example is this uniform random timer. So let's jump into the interface and take a peek at that. So if we right-click on the request here and we go add timer, and we choose constant timer. This is the simplest timer there is, which really just has one field, which is how much of a delay in milliseconds do you want to impose each time this timer is hit in the thread group, right? And by default, it's 300 milliseconds. That's a little bit less than a third of a second. Let's make it 800 milliseconds, which is most of a second, 8/10 of a second. And that means that every time we loop through here, after we do this request, we've got an 800 millisecond delay before we're going to do it again, right? Now, if we had instead put that timer up here, and if we had put the timer at the thread group level, what we're doing is actually saying this entire thread of all of its tasks that might be in here would have to run before that timer would happen. So I'm showing you, I'm kind of jumping ahead, but I'm showing an example of scoping, which is that where you put things does matter. We'll get back to scoping later in the course. I'm going to delete this for now. Okay, so we've got our thread group, we've got our HTTP request, and we've got our constant timer. Let's now talk about the next kind of timer we're going to cover in today's course, which is the uniform random timer. Just take what we just learned about the constant timer and add the ability to have a random amount of additional delay imposed. So down here where it says constant delay offset, if I set this to 800, that's what we had in the constant timer, remember? And then this is saying, and on top of that, I'm going to add, and let's make this 200. So on top of the 8/10 of a second, or 800 milliseconds, I'm going to add up to 200 milliseconds in delay. So the range here would be between 800 and, say, 1,000, which is 1 second. And those would be uniform. The random number here would play out between 0 and 200 in a uniform way. So if you ran this 1,000 times, you should get a pretty good curve of all the different values, right? And the reason we do this is that if you're deploying 100 users or 200 users or 1,000 users or 100,000 users, you don't want them all acting like exact robots. You want some variability in there, like real users in the real world, right? So that's why we use the uniform random timer. Now, we're not going to use it in this example right here, so I'm going to go ahead and delete that guy. So let's move on to the next item we want to cover in our first lesson here, which is assertions. So an assertion, if you look at the word, to assert means you want to be, if you look at the root, you want to be assured of something. And the reason why we use assertions is to make sure that the test is where we want it to be, or that the server is behaving the way we expect it to behave. So let's jump into the interface and take a look at what that looks like. So here's my HTTP request, and I want to make sure that when I send a request to blazedemo.com that I get back what I'm expecting. So let's right-click, and we'll add assertion, and we'll add a response assertion, right? Now, in assertion, like anything in JMeter, we could give it a name. We're going to leave that like it is. The first thing to look at here is response field to test, right? So text response is basically what comes back from the server. It's the HTML body, right? That's most commonly what you're going to use. I'm going to skip over document and come back to it in a second. URL sampled would be which URL did we hit, and the reason we might want to test that is that we may have calculated the URL and we may need to validate that it was legit. More likely, response code, 200 for OK, 400 for not found, 500 for server error, etc. By number, here by response message. So again, OK would be the case of 200, but in there's other examples more elaborate, like gateway unavailable, etc. Right? And then response headers. You may be familiar with that. Those are the headers that come back with the page. Look at that. Document is a special case, which is really only meant for functional testing when you're examining the contents of a Microsoft Office document or an Open Office document. You're literally looking in a Word doc or a PowerPoint or something for metadata or for content. So we're not going to use that. Let's use text response. Now, the next important thing to know about assertions is the pattern matching rules. Now, some of these sound kind of similar, which is, matches and equals. What's the difference there? And contains and substring. Super easy to remember this. The first two of these use regular expressions. So if you're familiar with Perl 5 or regular expressions, this lets you write a complex formula which figures out whether there's a match or not a match, right? And contains would be that the regular expression matches something in the page. Matches would be that the regular expression is all you got back. Like it would literally have to be the entire result is exactly what you get. And then if we switch over here to equals and substring, these just use plain text. So equals and substring match the actual characters you type and they're case sensitive. So again, equals would be the only thing you got back, and substring would be what you're typing was part of what came back, right? So in the example we want to use, we're going to look for the word welcome, right? And I just click add here. And I type welcome. Now I could actually use here substring or contains. This is a valid regular expression. It doesn't have anything fancy in it like stars and dots, etc., but it actually will work. Or I could use substring. So I'm going to leave it that. And now, so assertions. Again, the reason we're doing this is you want to make sure A, you ended up where you thought you ended up so that your navigation was correct, and B, sometimes a web server or an app can send back an HTTP 200 which assumes that's a valid page, but it could actually be a pretty printed error, which is an HTTP 200 page that comes back saying, sorry, your query was invalid, or whatever. And that's not what you really want. So in order to make sure that you're really getting what you expect and that you've navigated to where you really expect to be, you want to look for something in the page that you can search for. Now let's cover the case of not. So let's say that you know that you always print out something went wrong when something goes wrong. You send a pretty printed page back with something went wrong. You could set the assertion to say that you must not get something went wrong as the text that comes back in order to make sure you're not getting that kind of page, right? So there's lots of different ways you can use this. We're playing it pretty simple here. We just want to make sure we get the word welcome. And we'll see why in a sec. We'll look at the page that this is actually gonna hit. For now, we've built our thread group with one user. We've added a sampler, which is an HTTP request. We've added a constant timer to add a delay, and we have an assertion making sure that we get back what we're expecting to get back, right? Let's look at what we're going to do next. So now we're going to talk about listeners, and in particular the view results tree. But let's talk about what listeners are to begin with. So a listener literally listens to what's happening in the test. So it's paying attention to what's happening in the test and letting you follow it. And this will make more sense when I bring it into the test. So let's do that. So I'm going to come up here to this thread group, and I'm going to add a listener, and I'm going to add the view results tree listener, which is kind of your Swiss Army knife, super useful when you're running tests. And this is going to let us examine what's happening as the test is running locally here and kind of in a debug mode, right? And there are a few fields in here that I could just leave this the way it is and run my test now and we'd get some results, but let's take a look at what's here. Like anything, we can give it a name. This area where it has a file name, this lets us actually read from an existing file, which would be the results of a previously run test, or write to a file, okay? And then we can configure what we are keeping track of, right? So there are some defaults that are pretty good here, but if you wanted to add other things like what encoding was used, or XML response data, sample and error counts, etc., you could add new stuff. We're going to leave it like it is, right? And so let's actually just see how this works. So we'll go ahead and save. Here we go. We'll go ahead and save this and run it, okay? Now we see that we ran one HTTP request, and by the way, that's the label here. If I came up here and made this and we go back and we run this again, right? So that's actually more likely we might call that home page or give it some meaningful name. But I had it as HTTP request so you know what this is, since we're learning just these pieces right now, right? Okay, so now we can see that for each time this runs, we get data back, right? We get the result. Now this shows that, for instance, the thread name was thread group 1-1. Well, what does that mean? That means this was the first thread group and the first thread in that thread group. If we had several thread groups and each one was running, say, 100 different threads, we would have the number of the thread group and which thread had been running when we got this sample back, right? We have a timestamp for when it happened. Then we get some KPIs, some key performance indicators about load, connect latency, the size, and then were there errors found, what kind of data was it, what was the HTTP response code and message, etc. Here we have the headers and then the sample result fields. If we go over here, we can see what was the request we actually sent. So we sent this GET request. We didn't have any parameters on the command line. There was no post body or anything like that. We did not include any cookies, and we sent these headers. Now these headers are actually the defaults that we sent, right? We didn't actually specify any headers explicitly. These are what we got kind of for free. And then the response data is what we got back, right? So this is an HTML document. We can see right there, and we can see if we scroll down here, we can see there's that number, there's that text welcome. So this is a very simple travel site, and we'll see more of this as we go through the course. And the first thing it does is welcome you to the Simple Travel Agency, and that's why our assertion passed. Now, if we go back to the assertion, and we change this to deliberately break it and put welcome AAA, right? And then we run it again. Here's what a failure due to an assertion looks like. So first of all, the request, even though the request itself came back as a 200, which is an OK, right? But it shows as a failure in the test. Why is that? Well, if we expand this, we can see that there was a response assertion and it failed, right? And the reason it failed was it was expecting to contain welcome AAA, right? So now we can see how an assertion lets you examine what's happening to determine whether it succeeded or failed, and then the listener itself is what lets you watch all of this as you're building your test. So let's take a look at what we covered. First of all, we looked at thread groups, and thread groups are the things that launch new users or new threads into your test, right? And we'll talk later in the class about how to do some more advanced ways to launch thread groups. The simple case is just to create a thread group, give it a number of threads to go to, give it a ramp up time to go to, and decide whether it should loop or whether they should all execute just once, right? Then we looked at samplers, right? And samplers are really the workhorse of JMeter. They're the things that make the requests out on the wire. HTTP request, could be Java program that makes requests, could be a number of different ways that you are making requests. They're the things that do the work. Then timers, remember, a timer wasn't something that counts the time to track how long something's taken. It's really the reverse, which is the timers impose a delay to make your flow more realistic, right? So they add that user think time that they might use while they're filling out a form or whatever. And then assertions let us be assured that we got back what we expected to get back. And it's important to not just assume everything's fine. It's good to put assertions in really for every action to make sure that you're getting back what you expect to get. And then finally, listeners, the view results tree. Now, before we wrap up for today, I want to say something about listeners, which, if we go back, so this listener, this view results tree listener, is super valuable, super useful for what we're doing here. And if I, just to give an example, if I were to come back here and make the thread group run, 10 threads, let's make it 9 threads actually, and we were to run this, you'll see, and I can clear the results too, so it's clean, right? If I run it, we'll actually see it deliver all those requests. And I guess I left the assertion still bad. We could change this back to the good. All this examining that it's doing to make sure that everything is okay when the listener is running here This actually uses memory and CPU, right? And so when you're troubleshooting this, it's critical, it's useful, it's great. But when you are running a test at scale, when you actually want to run a load test, a bigger test, it's super important that you actually not have listeners running in your test plan, right? And you don't have to delete them. All you need to do is right-click and choose Disable, and you'll see that it turns gray. Right? And so that's now disabled. So just a good tip for you to remember, when you're running at scale, you don't want your listeners running. You toggle them on for debugging, you toggle them off for running at scale. So that wraps up what we're covering in this lesson. Here's your homework. You should do this before you move on to the next class. Just create a new test plan or script. Make sure you have a thread group, obviously, and then within that thread group, put 2 HTTP samplers, one going to blazedemo.com, one going to blazedemo.com/vacation.html. Then add timers. Why don't you do a constant to one of those and uniform random to the second one. And then assertions. Do a response assertion for each of those, making sure that the text that some piece of text that comes back on that page is there. Of course, add a view tree listener and run your test.